Welcome to the project demonstration of IoT water quality monitoring system by using Raspberry Pi in SVM, so the support vector machine. So here we are going to identify the water quality with the help of 4 sensors. Those are pH sensor and turbidity and TDS and temperature. So temperature is from DS18B20, remaining turbidity sensor and TDS is connected to the nano board. So these 4 sensors interface to the Arduino nano board, and from here we are going to convert this analog data. As we are using these sensors are provided the analog data that will be converted into the digital, to the serial. So that will be done by this nano board, and from there the transmitting pin is connected to the receiving pin of our Raspberry Pi 3 B+ model we are using, and from there we are going to display in the status on the 16:2 LCD screen. And on this one connected at the pin number 9, 10, 11 and 17, 27, 22 pins, and pH sensor connected at the A0 pin of our nano board, and A1 for this turbidity sensor, and A2 for TDS sensor, and pin number 10 for this DS18B20. pH sensor interfaces to the nano board through this driver, a BNC connected driver through this converter amplifier. So and same for TDS also connected to the nano board through this amplifier. Same for turbidity, this is the amplifier for the turbidity sensor. So here we are going to calculate the water quality, whether it is good for the drinking or bad. That status will be displayed on the LCD screen. Whenever the total 4 sensors are provided the sufficient values or normal values, then that will be as a good for drinking, and is there any abnormal detected, and that will be bad. So this good and bad will be decided by the SVM support vector machine inside this, so which will take the decision based on the linear regression algorithm. So based on that we are going to identify the system water quality, and same data will be uploaded to the ThinkSpeak cloud platform. So first one is the turbidity, temperature in degree centigrade, turbidity in NTU units, degree centigrade for the temperature, and next TDS for the parts per million ppm, and pH is 0 to 14 values. So the first of all before on the kit on the hotspots, go to hotspot settings of your phone and change the hotspot name to project 5974. Configure that to project 5974 without any space, without any capital letter. Password should be 123456789. After that, on the data and hotspots, now we can see 0 devices connected here. And now on the power supply to the kit, and also connect the battery. First step on the hotspot, second step on the power supply to the Raspberry Pi, and third is connect the 9 volts battery to the pH sensor. Now we can see 1 device connected, right? And now log into the ThinkSpeak cloud platform with the given credentials. While scrolling, don't touch on the blue bar. Between that you can scroll. If you hold the blue bar, then these graphs will be interchanged. Right, now you can see the data is uploading now. Just now we got the new data. So turbidity is 18. Now let us place this. So turbidity is provide the fast wave response, but TDS will take 20 seconds maximum. And let us place the temperature sensor, and pH already fill this water, so you can place this later in the abnormal water. So when this 4 parameters are captured properly, then only it will analyze this data. After analyzing, it will display whether it is good or not good. Right. Meanwhile, we can see download the data. We can download that, we can erase that. So for downloading, data import export. See, right, we got the TDS value also. Now it is 58. So data import export and download. So it will open an Excel sheet. Now let us place this in bore water. So let me place this in abnormal water. So we are inserted that into this bore water. Same, it will take maximum of 20 to 30 seconds for stabilization of this TDS values and pH. These are the data which I have downloaded till now. Right. So this is temperature, turbidity, and TDS and pH values. Along with the date and time, we will get all this data, and you can erase that. So go to my channels. Channel settings. Data import export to download the data. Right. We can see that it's not good, as we got the TDS values. Coming to the threshold values, because in the space, so SVM, we need to provide the threshold values also. Clear channel, only do clear channel, don't delete. Right. So here private view to see the graphs, live parameters, channel settings to clear channel, data import export to download the data. Right. Now coming to the threshold values. So temperature is 50 degrees centigrade, and the next turbidity is for 150 maximum, and TDS is 200. Below 200 is a good quality, and 200 to 500 is normal. So we took the good quality only. That's why we kept the limitation for 200 ppm, the parts per million, and pH is 6.5 to 7.5. Right, so this is the breadboard to distribute the 5 volts power supply, which is taken from this Raspberry Pi 3 B plus board, and from there to we are distributing the all over the input and output modules directly. And is Pi 3 B plus coded with 32 GB class 10 memory card. In that we have loaded Buster OS initially, and thereafter we have installed the Scikit learner, which is the main module which is used to execute the SVM modules. And from there we are going to do the classifications and analyzing and displaying the quality of the water.